Welcome to Season 2 of the Carroll-Wells Gradient. In this episode, we step back. This is Episode 14, Layer 14, Observational Synthesis, where we ask how everything we've discussed so far, geometry, entropy, persistence, life, awareness, collapse, thermodynamics, gravity, and testable predictions, fits together in what we actually observe. This layer is not about adding new ideas. It is about seeing what is already there. Up to this point, we've treated observations as individual probes. Background radiation, galaxy surveys, redshift measurements, void statistics, lensing maps, and structure growth are often discussed as separate data sets, each answering a different question. But from the perspective of persistence, these are not separate observations. They are different views of the same underlying record. The large-scale structure of the universe, the cosmic web, is not just a distribution of matter. It is a memory structure. Filaments, clusters, and voids reflect where persistence succeeded, where structure accumulated, and where cost could be paid over cosmic time. The cosmic web is shaped by gravity, but gravity itself is constrained by thermodynamics and information. What survives at large scales is what could remain coherent while exporting entropy. In this sense, the web is not accidental. It is the accumulated result of persistence navigating constraint. Redshift provides another layer of the record. We often think of redshift simply as distance or expansion, but it is also history. Light carries information about when and where it was emitted, and redshift encodes how much the universe has changed since that moment. Every redshift measurement is a timestamp. Every survey is a slice through time. When we look deeper into space, we are not just looking farther away, we are reading earlier entries in the persistence ledger. Voids complete the picture. Voids are sometimes described as empty regions, but from a persistence perspective, they are records of absence. They show where structure could not persist, where matter was displaced, and where cost favored evacuation rather than accumulation. Voids preserve information precisely because so little happens inside them. They are protected from constant reprocessing. Their shapes, alignments, and correlations encode long-term constraints that survive smoothing and collapse elsewhere. Voids are not gaps in the data. They are part of the data. When these elements are viewed together, cosmic web, redshift, voids, background signals, and structure growth, they form what can be called a universal persistence map. This map is not stored in any single place. It is distributed across space, time, and scale. It does not record events. It records constraints. What structures could form? What structures could last? What structures failed? The map is not written in symbols. It is written in geometry. This is why observational synthesis matters. No single dataset can reveal persistence on its own, but together they show a coherent picture, a universe that remembers not in detail, but in structure. Persistence does not remember stories. It remembers what worked. Layer 14 does not claim that the universe is conscious or purposeful. It does not assign meaning to structure. What it shows is something quieter and more defensible. History is not erased. It is encoded. The universe carries its past forward not as narrative, but as constraint. Every observation we make is a partial reading of that record. This is why consistency across observations matters more than any single anomaly. When independent probes tell the same story, they are pointing to underlying structure that survived every filter we know how to apply. At this layer, the framework closes its observational loop. We began with persistence as a simple idea, what lasts. We end with a map that shows how lasting shapes what we see. The universe does not reset, it accumulates. The map is not something the universe consults. The map is the memory. In the final layer, we turn inward one last time. We ask what it means for a universe that remembers through structure to eventually contain systems that reflect on that memory, systems that study the map and recognize themselves within it. I'm Charles Carroll. Thank you for listening to episode 14. Join us next time for episode 15, layer 15, the reflective layer, when a civilization learns how the universe learns. There, we'll explore science itself as a persistence process and what it means to be part of a universe that studies its own structure.